operating system class. So in today's class, we will be extending the topic which we were getting towards the memory management. So earlier we have talked about first in first out algorithm. Next one we have talked about this optimal replacement algorithm, and now third one. Now we are going to look into the least recently used memory management algorithm. So this was the third algorithm what we are going to focus it on. So in this algorithm, what was the core concept was, we are going to use a word called as counters. We are going to use a word called as counters. So you know that counters are going to count how many number of times the thing is going to be iterated, etc. Right? So I is equals to 0, I is equals to 1, I equals to 2. In this way, you are going to increment the content, and thereby you know how much it is going to be taken up. In this model, we are able to know the importance of a counter. So in the optimal replacement, we have to predict the future. In the optimal replacement, we have to know what will happen tomorrow. But in this least recently used, we have to understand what happened past. What happened past. So based on the past values, we are now estimating the frame. So that is what we are going to take up in the least recently used. Okay, one frame was not used for 4 times. One frame was not used for 2 times. One frame was not used for 1 time. That means the longest frame which has not been used, that will be replaced. Got it? So I am using one device for recent, another device very recent, and another device I am not using for 1 month. That means that 1 month device which I am not using is the least recently used. So that item I am going to replace it. So where we are going to call it as the least recently used algorithm, right? We have a pens. In that pen I have red ink, green ink, and blue ink. So most black ink. So red, green, blue, and black ink. 4 pens I am going to write. So mostly what ink I do use, I use a blue ink, green ink, and red ink. But I will never use the green ink. So when I have to replace some other pen, so which color I can replace is because the green color I am not going to use most frequently. So that item I am going to replace. So that is what we are going to understand the value that is least recently used. And one more concept was, when we are going to use a counters, we have to reinitialize. We have to reinitialize the counter to 1 if there was a hit. If there was hit, that means if there is no page fault, what was the default rule was, I have to reinitialize the counter. So that was one more condition pertained towards using the least recently used. So least recently used, you can use counters or we can use stacks. That is done. Next one. When I am going to use a counter, I have to reinitialize the counter to 1, and thereby it has to be incremented. So if there is a page fault, then you continue the increment. If there is no page fault, we have to reinitialize the counter. I will tell you this example when you will have a clear-cut understanding what was the counter and how we are going to take it. So as a whole, we are now dealing with an algorithm called as least recently used. In this least recently used, we will pick up a page which is not used for the longer period of time, which has not been used in the most amount of time, or the longer period of time, which is not going to be used. That item we are going to replace. So that is the core agenda of this algorithm. Okay, fine. Now let us start this algorithm. We are going to have the memory strings, that is 7, 0, 1, or 2. 20 entries are going to be part of this. Now what we are going to do is, let us say page table. Let us take page table, and page table size it is going to be some 3. And initially it was empty. Initially it was empty. So first of all, I'm going to ask for 7. So 7 was not available in the page table. So obviously I'm going to use the empty cell, and obviously it is taken up as a page fault cell. Next, CV was asking for 0. 0 was not in the page table. So 0 has been included in the page table, and there is no replacement policy. The reason was it is empty. Next one was I'm going to have frame number 1. So again, page table was still empty. So that is the reason why 1 we are going to insert into the page table, and we are going to use this aspect as a empty cell, and that is going to be treated as a page fault. Fine. Now, assume I am going to use the counters. Assume I am going to use the value of counters. Now, in this case, first case, 7 value was 1. Second case, 7 value was 2. 0 value was 1. Next, 7 value was 3. 0 value was 2. 1 value was 1. So we are going to use the value of counters here. So this is the increment value, these are the frame contents. Got it? Next, I have to replace. Now CPU was asking page number 2. Now which I have to replace? As per the definition, replace the pages that has not been used in the most amount of time. Replace the pages that has not been used for the most amount of time. That means in this item, 7 is going to be not used for 3 times, 0 for 2 times, 1 for 2 times. So I can choose 7 for replacement. Therefore, now instead of 7, I am going to replace it with 2 here, that is 0 and 1. Now what is the counter value? 7 is deleted, right? So now I am going to get the value of 2. It is first occurrence. 0 it was 2. Now it is incremented to 1. 1 was 1. Now we are going to increment the value. Now we are going to say increment or decrement the value. So this is the status here. Next one. Next. So we talked about 7, 0, 1, 2. Okay. Now see here. 0. 0 is going to be the page table. That means there was a hit. There was a hit operation. There is no question of replacement. But still, say reinitialize the counter to 1 if there was a hit. Reinitialize the counter if there was a hit, even though there is no page fault and it has to be incremented right away. So obviously, what we have to say, 2 value was incremented to 2 because it was 1, and now we are going to get the value of 0. Earlier value of 0 was 3. Now 0 was converted to 2. This is the observation what we have to understand while debugging the algorithm approach. 1 now it is incremented to 2. So since 0 was in the page table, there is no page fault. I agree. I am going to agree. But when there is a reiterated value for a hit, the counter has to be reinitialized to the starting position. That was the compulsory condition what we are going to meet up in the least recently used algorithm. So we have to reinitialize the counter value if there was a hit. That is the agenda value. So we went for 3. Okay, fine. Now we are going to take a value called as 3. Now 201. Which one I have to replace? Value of this is 2. So now value of 2 was 2 times. Value of 0 was 1 time. Value of 1 was 3 times. So now we can see that counter is producing value as 3, and from 3 instances of time 1 is not going to be used. Therefore we have to replace it with 3. So it happens with 2, 0 and 3. It happens with 2, 0 and 3 with a page fault. Okay. Now let me know the latest values. 2 is incremented to 3. So 1 earlier 0 was 1. It is incremented to 2. Now 3 has just entered. So 3 value was only 1 in this case. Fine. Next one. Next one. I have to insert 4 in the frame. Is 4 is equals to 2? No. Is 4 is equals to 0? No. Is 4 is equals to 3? No. That means I have to replace the page. Which page I have to replace? I am going to use least recently used. So if it is least recently used, replace the page that has been not used frequently. 2 is not used for 3 times. 0 is not used for 1 time. 3 is not used for 1 time. That means I can change that number 2 here. I can replace it with 4. That means now the question is going to be converted as 4, 0 and 3. 4, 0 and 3. So now I am going to eliminate 2 here. 4 occurrences was 1 time. 0 occurrences was 3 times. 3 occurrences was 2 times. So that is how we are going to get this value. So now we have going to have this a value which is going to be reinitialized, and now we completed the value of 4 there. Next one, 2. 4 is equals to 2. 2 is equals to 0. 2 is equals to 3. Definitely there is a page fault. Okay, what should I do if a page fault comes? I have to replace the page. Which page I have to replace? See the counter. In this counter, which value is greater, you go and replace it. As simple as such. So 1, 3, 4. Which is going to be greater number? 0 is going to be the greater number. Okay, now you can replace 0 with 2. That means 4, 2, and 3. Okay, then now set the counter values. 4 is incremented to 2. 2 is entered for the first time. 3 is incremented to 3. That is how we are going to get. Next one. Value 0. Value 0. 4 compared with 0. 2 compared with 0. 0 compared with 3. At any time there is no satisfaction. Obviously, it is going to lead to a page fault. Page fault came. I have to replace the page. Okay, replace it. How can I replace? Replace with an algorithm called as least recently used. What is this algorithm? So replace the page which has not been used for the more amount of time. That means 4 occurrences is 2, 2 occurrences is 1, 3 occurrences is 3. So from last 3 times, page number 3 is not going to be used. Therefore, I can replace it with 3. That means now for frame number 2. So I think we went wrong here. So 403. Next one we are going to have this 2 here. So 2 was available. 403 here. So we will be getting this value. One second. So 0 is replaced with 2 and 3 here. So 4 occurrences was 2, 0 occurrences was 4, 2 occurrences was 1, 3 occurrences was with 3 here. Now 3 I have to replace. Now you can see here 3 is going to be from the more amount of time. Therefore, what we can do is there is a hit here. There was a hit here. That means we have to reinitialize the counter. So if I am going to find an item in the content, definitely you have to reinitialize the counter. There is no question of a page fault. That means what was the current state? 4 is incremented to 3, 2 is incremented to 2, then 3 is going to be reinitialized to 0. 3 is going to be reinitialized to 0. That was the second item what we are going to take up. Next, 0. Comparison with 4, comparison with 3, comparison with 3. So obviously there is no item. I have to go with page fault. Then which place I have to replace it? Whether 4, whether 2, or whether 3. So just now 3 has came with one instance. So occurrences of 4 is more. Therefore I am going to replace it with 0, 2, and 3. 0, 2, and 3 we are going to replace it. Next one. Next one, the item was 3 here. So item was 3, it is found in the page table. Therefore, there is a bit here, but only the counter value is going to be implemented. 4 is 4, 2 is 3, and 3 is reinitialized to 1 because it is in the page table. Next one, 2. 2 is available in the page table. Therefore, again hit. But what is the difference? Counter value will be increased. 4 occurrences is 5 times, 2 occurrences is for 4 times, 2 occurrences is for 0 time because second time we are going to get this 2 here. So 0 occurrences was reinitialized to 1 and 3 we are going to change it to 2 times here. Fine. Next one. 1. 1. Is 0 equals to 1? No. Is 1 equals to 2? No. Is 1 equals to 3? No. Definitely there is a page fault. Definitely there is a page fault. Okay, I have to replace the page. Which page I have to replace? Least recently used. Replace the page that has not been used for the most amount of time. For 5 times, 4 is not being used. So defaultly you can replace it because it is greater than 1, it is greater than 2. Therefore, what we can do is we can replace 4 with 1. That means it is going to be 1, 2, and 3. So 1 occurrence is for 1 time, 2 occurrences is implemented 2 times, 3 occurrences is implemented 3 times. So that was the new innovation what we are going to take up. Next one. Value 2 we are going to verify here. Yeah, it is in the page table. So again, there is one more thing. But still, counter value has to be implemented. What is the counter value we have to implement? So we have to reinitialize the count. So 1 is implemented to 2. 2 has just been taken up. So it is available in the page table. So we are reinitializing the value to the minimum value, that is 1. And 3 is implemented for 4 times. And 3 is implemented for 4 times. Next, I should get 0 here. 1 is equals to 0? No. 0 is equals to 2? No. 0 is equals to 3? No. Definitely 0 should be in the page table, so I have to go for replacement. How can I go for replacement? Use a technique called as least recently used. Replace the page that has not been used in the most amount of time. Okay, check that page. 1 from 2 times it is not. 2 only 1 time, but see 4 from past 4 intervals 3 is not going to be used. Therefore, least recently used. That means 3 is not being used for the 4 times. The value of counter is high. Just replace it. So therefore, instead of 3, I should be getting 0. That means 1, 2, and 0. 1, 2, and 0. Now increment the counters. 1 is incremented to 3. 2 is incremented to 2, value of 3 is gone, it is replaced with 0 and replaced with 0 and the occurrence was first time. So now 1 is already available in the page table, 1 is already available in the page table, therefore we have to just increment the counter. So earlier it is 3, now it is reinitialized to 0, 2 incremented to 3, 0 incremented to 2, that is done. Next, we have to get this 7. At any time, we have to get this 7. So 7 equals to 1, 7 equals to 2, 7 equals to 0. Definitely not available in the page table. We have to replace the page table. How can I replace the page table? Least recently used. What is the concept of least recently used? Replace the page that has not been used in the most amount of time. How do I know it is not used for most amount of time? Go and check the counters. Whatever counter value is high, just replace it. So 0, 3, 2. In this, 2 is going to have counter value highest 3. So defaultly replace the value of 2 there. That means I can replace it with 1, 7, and 0. 1, 7, and 0. So 1, 7, and 0, we are going to get this value here. Now, 1, it is going to be incremented to earlier this 1. So it is incremented to 2. So 2 I have replaced here. That means I am replacing with 7 with 1. And 0 is incremented for 3 times. 0 is incremented with 3 times. Fine. 7 is done. Okay. Page table. 0 is equals to 1. No. 0 is equals to 7. No. 0 is equals to 0. Yes. That means there is a hit here and there is no question of page fault. There is no question of page fault because item was found in the page table. No question of page fault. But still, counters should be reinitialized to 1 if there was a hit. So, what is the latest value of counter? The latest value of counter is, I can say, 1 is incremented to 3, 7 is incremented to 2, value of 0 was 3 times, Now value of 0 is reinitialized to 1. Value of 0 is reinitialized to 1. So that was the amendment one is going to close. Done. So this is going to be in the phase table. Similarly, 1 equals to 1, yeah, it is in the pit. So it is taken up as a pit value. Therefore, now I can just reinitialize the counters. How can I reinitialize the counter? One value is earlier was 3, reinitialized to 0. 7 value was 2, reinitialized to 3. 0 value was 1, reinitialized to 2. So now the total strings are done. Now let us calculate how many number of page faults has occurred. So 1, 2, 3, 4, 5, 6, 7. This is 7, 8, 9, 9, and 10, and 11. So 12 number of page faults should happen. So somewhere we have done this problem. So let us iterate the process again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So somewhere we went wrong. We create the process, but the algorithm orientation will not change. So let us reiterate the process again with the same steps. But the concept is will be concrete and it will not be taken up. We should get the value of 12 or 11. So let us write the strings again. So we are going to use the algorithm called as least recently used. The strings will be 7, 0, 1, 2, 0, 3, 0. Let us write the strings again. The strings will be 7, 0, 1, 2, 0, 3, 0, 3, 0, 4, 2, 3, 0, 3, 2, 1, 2, 0, 1, 7, 0, 1. So 7, 0, 1, 2, 0, 3, 0, 4, 2, 3, 0, 3, 2, 1, 2, 0, 1, 7, 0, 1. So these are the string sizes. Now, page table size is equals to some 3 least recently used we are discussing. Replace the page which is not going to be used for the most amount of time. So page table size equals to 3 and we need a counter which is going to be incremented always, and if there is no page fault, we have to reinitialize. If we are going to get a hit that is no page fault, then what I have to do? I have to reinitialize. To 1. We have to reinitialize to 1. That is the compulsory condition what we are going to take. So initially page table was empty. So this we are going to call it as an empty here. So 7, we are going to get a value inside. So value of 7 is 1. Next I am going to get 7 and 0. So 0 value was 1, 7 value was incremented to 2. So 7 and 0. Next one we are going to get the values as 7, 0 and 1. So that means at this case 7 value was 3, 0 value was 2, 1 value was 1. This is the first condition what we are going to take up. We have taken up 3 strings. Now we are going to verify 2. So which I have to replace? The value which of the counter is greater. 3 is greater, right? So I have to initialize to 2, 0 will be 3 and 1 will be 2. That means it is 2, 0 and 1. 2, 0 and 1 we are going to take up. Next one, 0 was inside the page table. So there is no question of replacement. So there is a hit here, but still the counter value has to be reinitialized. Value was 2, 0 is going to be replaced to 0. So this is page fault number 1, page fault number 2, page fault number 3. Page fault number 4. So 1 is going to be incremented to 3 times. This is all done. Next, what we are going to take? 3. 3 is not in the page table. 2, 2, 2, 0, 1, 3. So obviously we have to go for replacement. What I have to replace? The counter value which is bigger, that we just replace it. That means 2, 0 and 3. 2, 0 and 3. That I am going to get it. So 2 is incremented to 3 times, 0 is incremented to 2 times, 1 is incremented, 1 is now replaced with the value called as 3, and it is for value of 3 and it is with 1. So we have done with 3. Next step. Next step. 0 is there, right? So 0 is again found in the page table, but still I can say there was a hit. If still there is a hit, still the counter is going to be increased. 2 is incremented to 4 times, 0 is incremented to 0, that is the starting, that is increment value was 1, and 3 is going to be incremented to 2 here. Next one, I am going to have the value of 4. So which I have to replace? 2 occurrences was 4 times, just replace 2. That means it became 4, 0, 3. That means value of 4 is now 1, value of 0 is incremented to 2, value of 3 is incremented to 3. Then we have taken up with these items. Next one, 2. So, which I have to replace? The count which is more. The value of 3 is more, right? So, I'm going to say 4, 0, and 2. 4, 0, and 2. That means 4 is incremented to 2. At this case, 4 is incremented to 2. 0 is incremented to 3 times. Now, 3 was replaced with 2 and 2. A counter value hit is there, then it is going to be only 1. So it is reinitialized to 1 here. Next, I have to get this 3 here. How to get the 3? Which to replace? So 0 occurrences for 3 times. So just go and replace it. So 4, 3, and 2. Now, what is the counter value? 4 is incremented for 3 times. 0 is replaced with 3 with 1 time. 2 earlier it is 1 time. Now the occurrences was for 2 times. Next one. 3, which to replace 3? You replace with 4. How you are telling? Counter value which is more, that you have to replace it. Simple. So 3, 1 second. So 3 is already inside the page table. 3 is already inside the page table. So 4 is equals to 3, no, 3 is equals to 3, yes. So obviously I'm going to get the value of hit here. So when there is a hit, I'm going to say 4 is initialized to 3. 3 is reinitialized to the basic value 1, and 2 is going to be, so value of 4, value of 3 is reinitialized to 1 here. So I think there is no hit here. So I have already taken it. So what is going to happen was the value of 3, there is no question of counter value. Counter value is already there. So 3 is reinitialized to 1. So again 2. That means 4 is reinitialized to 3. 3 is initialized to 2 times. 2 is reinitialized to 0 times. That we are going to call it as hit here. Next step. 1 is going to be taken up. So then I'm going to get this 1 here. So what I have to replace? Replace it with 4. Replace it with 4. So that means 1, 3, and 2. 1, 3, and 2 is going to be the values. So 1 is for 1 time, 3 is for 3 times, 2 is for 2 times. 2 is for 2 times. So obviously we are going to get the value as 1, 3, and 2. Now compare the page table. 2 is available here. So there is a hit, but only the counter value is going to be changed. 1 incremented to 2, 3 incremented to 4, and 2 is reinitialized to 1. Next one, 0. So occurrences of 3 is more. So I can say 1, 0, and 2. 1, 0, and 2. Now what is the counter values? So 1 is for 3 times. 3 is replaced with 0. So 0 is for 1 time. 2 is incremented to 2 times. Next one, I have to get 1 here. So 1, it is available in the page table. Though there we are going to get the value called as hit here. So that means it is 1 is for 1 time, 0 is for 2 times, 2 is for 3 times, 2 is for 3 times. So we got the counter value right now. Next one we have to replace it. Next one we have to replace it with the 7 here. How to replace it with 7? So 717072. Obviously 7 is not in the table, so it is going to create a page fault. So 7, how can I replace it? The counter which is going to have the most count. So that is 2 is going to have 3 occurrences. So it is 1, 0 and 7. It is 1, 0 and 7. So the total number of occurrences I can see here. So 107. So 1 is implemented to 2, 0 is implemented to 3 times, 2 is replaced with 7 and its occurrence plus for 1 time. Next one, hit. That is 0 is already available, 1 is already available, 2 hits are there. So 1 it is going to be initialized to 1, 0 is initialized to 4, 7 is initialized to 2, and 1 it is going to be reinitialized. So 1 is So 0 is initialized to 1 here, and 1 is implemented to 2. So again 1 it is initialized to 1, 0 is initialized to 2, 7 is initialized to 3. Now the counters are done. So now calculate the number of hits. Calculate the number of page faults. Calculate the number of page faults. So it is 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11. Again, I'm going to get only the 11 somewhere we went wrong. So I'll just verify it. So the first thing will be 7. Second should be 7. Second should be 70. Third should be 701. Fourth should be 201, 203, 403, 402, 432. And I should get here as 032. 0 we have this. We have listed here 032. This item we have listed. Take a note. This iterative process we have not taken up, and rest are common 132, 102, 107. So we have not replaced the page. We have not replaced the page for 0. We have to replace the page for 0, that is 032. We have missed it. So if we are going to take up 032 at that time, definitely we should get a total number of page faults will be grabbed. Total number of page faults should be 12. So the process is going to be same. You don't have any change in the iteration or working of an algorithm. The algorithm procedure is going to be same, but the only difference was if you are going to miss one reference stream, see the total number of page faults are going to be varied, and the end answer is going to be affected. So in the first round, we taken the same example. We got 15 page faults. Next, we have taken the same example and we have reiterated for optimal page replacement. There we got 9 page faults. But now in this least recently used, we have to get 12 page faults. It is a standard example. So we should get 12 page fault. Of course, we got 11, but where was the mistake was we have forgot this 0 was in the reference string. So if I'm going to compute this 0, then I should get 032. So instead of 1, it is going to be replaced. So that was the mistake what we have taken. So total number of page faults will be some 12. So in the interest, I will explain it in our next class again, so that this error we are not going to get it again. So that is all for today. So in today's class, we have taken up this least recently used algorithm, and in this least recently used algorithm, the page which has been for the longest interval of time has to be replaced. That we have taken up, and we have solved with an example. This is all for today. Thank you for joining. Ending the class. So we will be having this attendance and ending the meeting. So we'll be having this hybrid the infrastructure feedback. You can give it up.